Okay, we're still discussing presentism and eternalism, this time based on the question, does time flow? We're going to look into an old discussion started by John McTaggart in 1908 when he wrote an article about time, and he distinguished two different understandings of time that he called the A series and the B series. So the A series says that time flows, there's a unique now, distinguishing or separating past from future. Whereas the B series says that no, there's no unique now. All times are equal, they're just distinguished by being either before or after each other. So this is quite similar then to the discussion between presentism, which corresponds then to the A series, and eternalism, which corresponds to the B series, although you can make different combinations, so it's not an exact match. But here we're looking into this old discussion because it has some arguments that are common in the discussion and which we need to look at in order to continue the discussion on presentism and eternalism. So especially I'm going to look at 4 arguments against presentism. Since I'm defending presentism, I need to have a response to these arguments. And here you see them. We will now, in the next 4 slides, I'll discuss each of the arguments. And then some might miss a 5th question about when we're discussing whether time flows. It's a standard question to ask, would it be possible that all motion stopped, but time was still flowing? And we'll get back to that in a later video with a 9.10 in its title. Then we'll return to that question. Now we'll look at these four arguments, and we'll start with the first one, which McTaggart had himself in his article. He argued that the A series is inconsistent, and thus he defended the B series. And his argument was that in the A series, they say that the same time can be both present and future and past, and this is inconsistent, which they don't do in the B series. They just say before and after. And the obvious reply, of course, to McTaggart is to say, well, it's always present or past relative to some point of time. But he replied to that reply, well, if you want to make that move, then you have to have a sort of meta series on time in order to arrange what is really past and what is really future, etc. But then you get the same problem, and you have to continue adding new time series in an eternal regress. I think that this is a poor objection, which seems to be based on his presupposition that all these times exist at the same time. There's no problem if you're a presentist and say that only the present exists. Then it's not the case that some point of time is both present and future, or future and past at the same time. So there's no inconsistency if we just describe it on the presuppositions of presentism. So I think that was not an important argument, but it's the argument that McTaggart gave against the A series to defend the B series. Argument number 2 is much more common. It says that there's no now in the laws of physics. We would expect, if presentism is correct, that now is really unique, then it should have a unique place in the laws of physics, but it doesn't, and so we shouldn't say that it's unique. Well, my reply is that in physics they do have t in their equation to refer to the point of time, and that can be now or it could be another time. But since the laws of nature are the same, both now and later, yesterday and today, there's no need to treat now as something special. So that's why they don't have their own notation, or you don't find now in the laws of physics, because the laws of nature are the same. But on the other hand, they do use now all the time, of course, to, for instance, if you ask how old is the universe, it will be implied how old is the universe now, and then they'll have to, if they need to say something is now and something will be future, they have to use their consciousness to determine when now is, and consciousness is not a part of physics. So they don't use now as its own term, but it is in use in practice all the time. And here are some especially relevant examples to mention, showing that there is a now in physics, in the laws of physics and in physical practice, you could say, but it's implicit. It doesn't need its own term, and still it's there. For instance, in quantum mechanics, where it's very common then to say that when we make an experiment, the result is open. It can be either this or that. So if you have an indeterminate interpretation, you will say that the result is open, which means that there's an important difference between the future where it's open and the past where it's not. So then now is distinguishing, is an important distinction between future and past, which would be against eternalism. Also, in quantum mechanics, you have the concept of entanglement, that two particles can be entangled, which means that then if you make one measurement on one particle, there will be at the very same time an effect happening, or something will happen to this other particle, even if it's on the other side of the universe. And this indicates a universal now, that something is now at the same point of time. Same thing happens at the same point of time all across the universe. So these are different examples then of there actually being a now implied in the laws of physics, against those who say that there's no now. You're right, they don't use the term now because they don't need it, since the laws of nature are the same now and tomorrow and yesterday. But still, the concept of now has an important role in physics and in how experiments are done and in how quantum mechanics are described. Argument number 3, it's pointless to ask how fast time flows. If time really flows, it seems we could ask, well, how fast does time flow then? But then it seems we can only give meaningless answers like, well, 60 minutes per hour or something like that. And so the argument is that if time flows, you should be able to give a meaningful answer to the question of how fast time flows. But since you can, it shows that we shouldn't think of time as something that flows. My answer to this is that it's not pointless to ask how fast time flows. We have, in order to create this concept of time, we have found different even motions or movements, and we have put them together into this one abstract motion that we say this is time moving, and which we can divide into parts, because then we can agree on when we met or how long it took, etc. So it started with quite even motions like the Earth rotating, etc., and then more and more exact motions and even motions have been found until they now landed on the oscillations in the cesium-133 atoms, which are very, very exact and can be used to make very exact measurements, very even and very stable, etc. But what this means is that we can answer the question of how fast time flows. And the most exact answer is that it flows as fast as 9,192,603,707 oscillations of the frequency of the cesium-133 atom in its ground state per second. Or we can say 24 hours per day, 60 minutes per hour, as fast as light used to travel 1,079,252,848.8 kilometers per hour, or about 1/24th of the Earth's rotation per hour, etc. You can object to this that, well, this is just circular definitions. They're all different motions that are defined in light of each other. And I say, yes, you're right, but it's not a vicious circle. It's like an English dictionary where all the words are defined in light of each other. Here are a lot of motions compared to each other to make this one abstract concept that we call time. And all these words, they make up what we call the English language. But the English language is not something in addition to the English words and their relation. And time is not something in addition to these motions that we have put together to make the one abstract motion that we call time. So we can meaningfully answer how fast time flows by giving different ways that are all related to each other in the same, to make one consistent abstract motion. That is the flow of time. So that was my reply to argument number 3, and then we'll do the last one, argument number 4. When physicists speak of space-time bending, it shows that time is part of this bigger entity called space-time. It has 4 dimensions. It's not just a word we made up by saying that different things move in the 3-dimensional world. It's this 4-dimensional thing which corresponds well to a block universe, but not to presentism. Well, to answer this objection, first we need to be precise about what we mean by a dimension, and we should then distinguish a spatial dimension from a mathematical dimension. Spatial dimension is a concept that makes sense by thinking of first 1 point, no extension, so it's 0 dimensions, but you can take this 1 point and drag it in one direction, then you get a line in 1 dimension. Then you can take the whole line and drag it in another direction, and you get a square then, or some 2-dimensional plane. And then you can take this whole plane and drag it in a 3rd direction to make a 3-dimensional object, a cube or something like that. But if you then move the whole cube in another direction, you're still in this 3-dimensional space. And what it means that this 3-dimensional space is that any point can be located by 3 variables then, or 3 coordinates, one for width, length, and height. So these are the 3 spatial dimensions. And we can use coordinates, numbers, to describe then the 3 spatial dimensions. But we can also add a lot of other coordinates, which are then just variables. For instance, a 4th variable, 4th number to represent time. So it could be our box today or yesterday. Or a 5th coordinate could be in what direction is this box headed, etc. We can add as many mathematical dimensions as we want, because that's just coordinate representing any variable. But that doesn't mean that there can be more spatial dimensions. There are 3 spatial dimensions that we need to locate a point in where it's located. All these other mathematical dimensions should not then confuse us into believing that mathematical dimension and spatial dimension is the same, or that there are more than 3 spatial dimensions. If you want to claim so, then you need to argue, explain, because we think of dimension, it's a word that makes us associate different parts of the world, and some people talk about there are 11 dimensions, but they're curled up so we can't see them. But if they're curled up, then they're curled up in our 3-dimensional space, and we can use 3 coordinates to pinpoint any point in this curled up thing. So you can use other variables and other dimensions, and that can make good sense. So that's nice, and still important difference. That's also in physics they do talk about to specify. Now it's spatial dimension, now it's other dimensions, time or something else. That means we have to decide then, should we think of space and time as something that can bend? It's nice to think of that, because if light is bending around the sun, for instance, it can seem like there's this medium that's being bent, and so it's just following a trajectory in this medium. But you can also think of it as just a helpful way of describing the trajectory that light has or some other particle has. But in reality, it's laws of nature determining that when you are moving next to a very massive object, you will move in this trajectory, etc. So you don't need to add a medium called space that can bend, because then you don't know what is this medium and how does it bend, and you get a lot of additional problems that you don't need, because you already have laws of nature and particles, and that gives you everything you need. So simple solution is clearly to say that there is no actually bending space. We have already explained all we need without adding that, and then we should not use it then we don't need to use it, or we don't need to reject presentism and accept a block universe because of this. We have a nice reply to the objection. That was my 4th and final objection, that I discussed, and showing that these 4 objections against presentism, none of them are very good, so I conclude that presentism is still a very defensible view.